In this video, we are going to learn how to take the derivative of e raised to a power. So when e is raised to some power and you want to take the derivative of that, you're going to just take e raised to the power as is, and then you're going to multiply that by whatever the derivative of the power is. Okay, so in this first example, we're being asked to find a first derivative. So on the first term, it's just my normal power rule, so I'm going to have a negative 8x once I derive that. And then I have minus, so then I have 7, and then the derivative of e to the x will just become e to the x times the derivative of x, which is just a 1. So my final answer would be a negative 8x minus a 7e to the x. So that would be my first derivative. Okay, so then on step 2, it now wants a second derivative. So looking at my first derivative, when I take the derivative of the negative 8x, I simply get negative 8. And then I have a minus. When I take the derivative of the 7e to the x, I get 7e to the x times the derivative of the power of x, which would just be a 1. So my final answer there would be a negative 8 minus 7e to the power of x. Okay, so now on this one, we're going to again start with a first derivative. So when you derive e to a power, you're going to leave it as e to whatever that power is. So negative 0.3x squared minus 1. But then you turn around and you multiply it by the derivative of the power. So on my power, I'm going to be doing the power rule. So when I pull the 2 to the front to multiply by the negative 0.3, that actually becomes a negative 0.6. And then I decrease the power of that x by 1. And then the derivative of my negative 1 would just be 0. So my final answer, typically what they'll do is they'll pull any numbers up front. So I have a negative 0.6. Go ahead and pull the x up front with it, and then times that e to the original power. So e to the negative 0.3x squared minus 1. So this would be my first derivative. Now in part 2 of this one, they're wanting me to look for increasing and decreasing intervals. So of course this is where I'm going to want to just make a sign chart. Or I'm going to want to first set the derivative equal to 0 so that I can make a sign chart, and then we'll see if we have any critical values. So if I go ahead and I take this derivative and I set it equal to 0, and I'm trying to solve for x, of course, first thing I notice is I could go ahead and just divide both sides by negative 0.6. Okay, and then so that would cancel, so we've got an x times an e to a negative 0.3x squared minus 1 is equal to 0. And so what I observe here, if you think about it, e is a base that's approximately 2.72. It's raised to some power. So this part of this particular of the first derivative, this will never be 0. So the only way a product can equal 0 is if some part of that product is 0. So if I know that e raised to a power is not equal to 0, then what that tells me is the only way this product could be 0 is if its x itself is equal to 0. So now I'll make my sign chart. Putting 0 in the middle, and so I want to plug in something bigger than 0, so I could use something simply like x equal 1, plug in something smaller than 0, so I could use negative 1, and remember you're plugging these back into your first derivative. And so if I go back to my actual first derivative, plugging them in, you can just look right here, and you're just going to get on a calculator, plug those in, and I'll do that. I'll take a break, do that, and come back and report to you the values. Okay, so when I plugged in x equal negative 1 into my first derivative, I got a positive value out of that. When I plugged in x equal positive 1, I got a negative value. So what this tells me about my graph is that I'm going to be increasing here and then decreasing here. So my decreasing interval, notice, starts at 0 and goes to infinity, whereas my increasing interval starts at negative infinity and goes up to 0. Okay, final problem. I'm looking for a first derivative. On this, notice I'll have to do a product rule because I see two terms that are being multiplied. So remember that with the product rule, we'll take the derivative of this first term, so that will be a 6x squared, and that is multiplied by the second term, which is e to the power of 8 minus 7x to the fourth. And then we say plus, and we take the derivative of the second term, which is this e. So the derivative of e to a power is e to the power. So I get e to the power of 8 minus 7x to the fourth. And then it's multiplied by the derivative of that power. So the derivative of that power is negative 28x cubed. And then all of that is multiplied by the first term, which happens to be the 2x cubed. So now let me come back and we'll clean this up. So there's nothing on this first term that I can really simplify, so I'm just going to leave it just like that. But on the second term, notice that if we take the negative 28 times the 2, I get a negative 54. And then if I take x cubed times x cubed, negative 28 times 2 would be negative 56. Let me get that right. X cubed times x cubed would be x to the 6th. And then I still have my e to the power of 8 minus 7x to the 4th. Now, doesn't matter the order of the terms, so that's my order. This is their order. It's the same answer, but that would be the derivative.